There's a photo of a beach. Two people are sitting in deck chairs. Between them, an open umbrella, a towel on the sand, a surfboard. The woman has lifted her phone to take a picture, and here's what she's photographing. Behind them, sealing off the horizon from end to end, is a wall that goes from orange to black. The wall is moving. Nobody gets up. That photo was taken in the Gironde region of France, and the day it hit the internet, half the world said the same thing. This is a scene from the apocalypse. This summer, the same region burned again. This time 42,000 hectares turned to ash. The largest fire in France since the Second World War. 220,000 people were forced out of their homes. And this time, nobody shared the photo. So what changed in those 4 years? The answer isn't that summers got a little hotter. And it definitely isn't that there are more arsonists. The answer is something more unsettling than either. These fires are no longer victims of the weather. They are the weather. We're going to take that apart, step by step, and at the end we'll talk about what it has to do with you. Subscribe so you don't miss it. Summer isn't ending anytime soon. We have time. July 24th, 2026. 6:20 in the evening. Near Samos, a fire crew looks up at the sky. There's a black cloud sitting on top of the fire, and that cloud is turning electric. A few minutes later, a bolt of lightning comes out of the cloud and hits the ground. Where it lands, there is no fire. Now there is. That evening, the French Firefighters Federation put it on the record. The first Pyrocumulonimbus ever observed in the country's history. A fire cloud. Theodore Giannaros, a fire meteorologist at the National Observatory of Athens, describes it like this. This is not a one-way effect. Once the cloud forms, it becomes its own weather system. How? Medinash. The fire pushes heat and smoke upward. The smoke particles absorb solar radiation, which means the column heats itself further as it rises. The rising hot air creates a void above the fire, pulls in the surrounding air, and the winds these giant fires generate pass 160 kilometers an hour. Higher up, the air cools, water vapor condenses around the smoke particles, and the condensation itself releases latent heat energy. Did you catch what just happened? At this point, the cloud has started producing its own fuel. The result is a thunderstorm built on top of a wildfire. It has its own wind, its own lightning, its own cloud. The only thing missing is a weather presenter. And this storm doesn't stay low. 9 to 17 kilometers above sea level, there's a layer that passenger jets can't even reach. The stratosphere. Normally volcanoes are what get up there. An inventory study that swept every recorded event over 10 years found that 55% of documented firestorms carried their smoke to that boundary or beyond it. The massive particles released up there in a single fire season can rival a major volcanic eruption. The record was broken in 2023. 169 events worldwide. 142 of them in Canada alone. So what does that smoke do once it's up there? In 2019 and 2020, Australia's black summer fires pumped roughly 1 million tons of smoke into the stratosphere, the most powerful fire-driven disturbance of the atmosphere in observational history. Then researchers noticed something up there. The smoke particles had lowered nitrogen dioxide levels in the stratosphere, and that was the first link in a chemical chain that leads to ozone depletion. The bill for those fires came to a 1% loss of ozone. That same year, the ozone hole widened by 10%, around 2.5 million square kilometers. So a forest fire no longer just burns the forest. It undoes what the Montreal Protocol spent 40 years winning back. Now you're saying, fine, but clouds don't start fires. People start fires. And you're right. In Mediterranean Europe, the overwhelming majority of ignitions are human. Carelessness, a lighter, stubble burning, arson. But the match was always there. What changed isn't the match. It's the ground it lands on. Research shows that when the moisture content of dead vegetation drops below 20%, the probability of ignition jumps sharply. This year, Western Europe lived through the hottest June in its records, 3.05 degrees above normal. In France and Germany, the anomaly hit 9 degrees. Southern Spain saw 45.1. A climate attribution study calculated that this kind of heat is 200 times more likely today than it was just 20 years ago. 50 years ago, it was very nearly impossible. Which is why the ledger looks like this. Spain, 186,000 hectares and 15 lives. The Avila fire alone, at 50,000 hectares, is the largest on the country's record. France, 116,000 hectares, a modern-era record. Italy, 69,000 hectares. Portugal, the smoke column out of Vuzela stretched 620 kilometers. Greece, 5 emergency workers in a single week. The European Union total on the 29th of July stood at 434,000 hectares. The 20-year average is 172,000. That's 2.5 times as much, and summer has only just passed the halfway mark. And do you know what last year's record was? 1,079,000 hectares. The worst since records began. This is the year lining up to beat it. And this is not a European story. In Turkey, between 2010 and 2019, an average of 7,000 hectares of forest burned every year. Since 2020, that number is 49,000 hectares. 7 times higher. Last year, 6,800 fires broke out across 53 provinces. More than 80,000 hectares turned to ash. And the worst of it, 20,000 hectares hit Izmir. But the heaviest loss wasn't measured in hectares. In Sayed Ghazi, in the province of Eskişehir, 5 forest workers and 5 volunteers from the country's Search and Rescue Association were caught in the flames when the wind suddenly changed direction. 10 people. A shift in the wind. And in France, the thing generating that wind was the fire's own cloud. So what if you're nowhere near a fire? What if you're sitting in a flat hundreds of kilometers from the nearest forest? The smoke finds you. That single Portuguese fire sent a smoke column 620 kilometers. Picture a band of smoke running roughly the distance from Paris to Marseille. This week, on the 31st of July, the European Office of the World Health Organization published a warning describing wildfire smoke as, quote, a frequently underestimated health risk. Here's why. These particles are small enough to cross from the lungs into the bloodstream. The global estimate is that wildfire smoke is linked to 677,000 premature deaths a year. You don't have to see the fire. Breathing is enough. But let me confess something. While I was putting this video together, a notification came up on my phone. Forest fires in 6 provinces. And I swiped past it without reading it. When I realized, I sat and looked at the screen for a while. A study published in 2019 measured exactly this. Researchers swept 2.8 billion geotagged tweets and found that the threshold at which people register weather as unusual resets itself roughly every 5 years. The reference point for what we call normal is the weather we lived through 2 to 8 years ago. And the most devastating sentence in the study is this one. Extreme heat continues to make people miserable. They just stop talking about it. So let's go back to that beach photo. The people in those deck chairs weren't stupid. It's not that they couldn't see the view. They were simply 4 years ahead of us. They had already learned not to get up, not to fold the umbrella, not to cut the holiday short. In 2022, that frame was a document of catastrophe. Today, it's an ordinary summer photo. What changed wasn't the view. It was us. Penny Endersby, the chief executive of the British Met Office, summed it up last week in a single sentence. This will not be a summer as usual. So maybe the question we should be asking isn't when will these fires end? Maybe the question is this. When was the last time you remembered what normal actually was? Worth thinking about.